Hello, this is Jordan Pennington. I'm with the Gold team, and this is my Project 2 presentation video. Okay, first, I imported the required libraries to perform the tasks needed for the rest of the project. These include import pandas as PD, import numpy as NP, and from Skippy import stats. Next, I imported and read the data frame, which was trained under train.csv. Here, I just went ahead and presented the data frame showing how many rows and columns were in the data frame, which was 8,068 and rows and 11 columns. And then I went ahead and ran the data types in order to understand the data and what needs adjusting. So the data types included ID, gender, ever married, age, graduated, profession, work experience, spending score, family size, var_1 segmentation. And these data types either had int64, object, or float64. Next, I use the df.describe function to describe the data to present things like max, mean, and average values. As you can tell, the max age is 89 and the min age is 18, which is a very diverse range. Work experience, the max work experience was 14 and the min was 0. And the average age is 43 and a half. The average work experience is 2.64, and the average family size is 2.85, almost 3. Next, I use the df.isNull function to find the missing values within the data set. As you can see, most of them don't have any missing values besides work experience and row 4, as we can see. And next, I went ahead and used the df.isNull.sum function so we could actually see how many were missing in each column. So ever married had 140 missing values, graduated had 78 missing values, profession had 124 missing values, work experience had 829 missing values, family size 335, and var_1 had 76 missing values. I went ahead and showed the shape of the data set before adjusting the missing values, so you can see that it worked. And then right here, I went ahead and dropped the columns I didn't think would be needed to predict customer category. And these columns were ID and var_1. I just didn't think that those would be necessary to predict customer category. So I went ahead and dropped them to get them out of the way. And then again, I showed the the shape of the data set after dropping those columns. You can see it went from 11 to 9. Then I went ahead and dropped the missing values because we don't need them for the final result and they're just in the way. And as you can see, the rows went down from 8,068 to 6,718. So that shows that the process worked. Next, I used df.duplicated to provide details of the duplicated values. You can see in row 8,065, there is a duplicated value. So I went ahead and dropped that duplicate. So you can see it went from, I went ahead and dropped the duplicate rows, my bad. So it went from 6,718 to 6,052. And I just went ahead and showed the data set again after dropping the columns and dropping all missing values and duplicated values. Next, I imported the libraries needed for the box plot, which is Seaborn and matplotlib.pyplot. And then I went ahead and used those libraries to perform the box plot to show the outliers in the data. After that, I went ahead and changed segmentation attribute to numerical, so it'd be easier to understand using get dummies. And then I presented the data frame of segmentation after using that formula. So you can see it changed from a categorical attribute to a numerical attribute, which is 0 and 1. Below is the correlation matrix, but it's limited because most attributes have categorical data instead of numerical. So the only ones that had numerical data were age, work experience, and family size. So I went ahead and did the correlation matrix for those three, which I think these three attributes will probably affect customer category more than anything. Next, I imported the required libraries to generate a heat map, which was Seaborn and matplotlib.inline. And then here I went ahead and put in the formula to generate the heat map to show the correlation between attributes. As you can see, we have age, work experience, and family size in the heat map. Then I went ahead and answered these couple questions. I believe this classification problem is a multi-class classification problem because there's multiple different attributes that will affect customer category, in my opinion. And then I believe I would use the OVA attribute or formula to predict this. I think it would be the most efficient and easiest method for this data set. And here I just went ahead and imported the libraries again because I've restarted after doing the progress report. So I had to import pandas, numpy, and skippy again. And here I went ahead and read the data set again and then presented the data frame once again. And then here, I didn't think that it would need standardized, but I went ahead and standardized age. So I went ahead and created the data frame to be standardized. And then I put in the formula to create a data frame object. And then here, this shows age standardized. And once again, I put honestly, I don't think the data needs to be standardized. But if there would be one that needed to be broken down, it'd be age because it's such a diverse range of data. And then again, I went ahead and converted segmentation to a numerical attribute as I did above. And that's showing that it worked. This data frame showing that it worked. I also converted ever married from a categorical attribute to a numerical attribute. As you can see, it went from yes and no to 0 and 1. Here I'm importing the required library for random data sampling with replacement. And then next, I created a list of items to randomly sample data, age 22, 38, 67, 67, and 40. And then I use this formula to randomly sample a list of data, which is the attribute age. And here I went ahead and displayed the updated random selections using the data sampling, which I put in the age wanted to be a list of 3, so I got 67, 38, and 40. Here, I imported the required libraries for tree-based classification in Python, which is NumPy, Pandas, Sklearn metrics, Sklearn model selection, Sklearn tree, and Matplotlib. Here I imported the dataset and displayed the dataset information for the tree-based classification. Next, I created the function to split the dataset into features and target variables. Then I separated the target variables, and then next I split the dataset into train and test, as you can see below. Next, created the classifier object and imported training, as you can see. Random state 100, max step 3, and min samples leaf was 5. Next, this is decision tree with entropy and performing training. Again, here's entropy. Next I created the function to make predictions. Then I did the placeholder function for challenge for accuracy. Then I created the function to plot the decision tree right here. And finally, I tried to make the decision tree work, but for some reason it would not accurately depict due to the female attribute not wanting to convert to float. And I worked on this forever to try to figure out why this wouldn't convert, why the female wouldn't convert to float, and I just couldn't figure it out. But finally, here's what I found from working through this project. From using the data for the goal team, I have produced many findings about my data. For example, customer category doesn't rely on every single attribute within the data set. Because of this, I cut two columns, var_1 and ID, because they were not useful to predicting customer category. I also found that the attributes ever married, graduated, profession, family size, and work experience had missing or null values. To take care of this, I dropped those values to get them out of the way. I also dropped all duplicates to make the data set more accurate. I then generated a box plot, and by that box plot, you can see age has the most diverse range between the attributes. Next, to better understand the data, I converted segmentation and ever married to numerical data to make the data set easier to understand. Finally, I created a random sample heat map and decision tree to provide understanding to my data set. From this, I believe my hypothesis was correct. Only certain attributes are necessary to predict customer category. And these attributes I think were the most necessary to predict customer category were age or work experience and family size. So this is my project 2 for the goal team. I hope I did a good job, and thank you.